make a little graph here. We have our waveform happening from left to right there. And on the left side, on that axis, we have our 16-bit in the example of a CD. And this is our bit depth. Basically, this is how many ones and zeros can be used to define what the level of that wave is. And this defines amplitude. So how loud or soft, how much intensity or little amount of intensity the wave is enacting. On the bottom part, we have our samples per second, and this is measured in the standard for CDs is 44,100 samples per second, and this is definitive of time. So as the wave moves from left to right, it's synonymous with moving through time. So we take samples of these different spots, and we're taking these samples 44,100 times per second, and at each sample we measure with our 16 bits what our specific amplitude level is, and that information is taken in these snapshots, and each snapshot is pieced back together at that same sample rate of 44,100 times per second, and we can recreate that wave, redraw it back together with those little snapshots. So we have 16-bit, which is what we use for CD quality audio, and basically with 16 ones and zeros, you have 65,536 steps. So these are discrete amplitude levels that we can define with these 16 bits of information. So we have a very fine scale there, if you look at it that way, 65,000 steps. And we're doing that, 44,100 times per second. But they came out with 24-bit, which gives us 24 ones and zeros, which is not just 50% more, but exponentially more because of how binary code works. So what we have is 16,777,216 steps available. This gives us a much higher resolution, a lot more discrete amplitude levels that we can define it in, and we're still doing that 44,100 times per second, oftentimes with 24-bit, but oftentimes we use higher sample rates, 48,000 times per second, 96,000 times per second, 192,000 times per second. So we're getting very detailed, a lot of resolution here, and a lot of bits that are being used to define this resolution. So, 44,100 times per second. It's often shown as 44.1 kilohertz, and this was chosen for use on CDs and has become the standard sample rate for music because of it. Next is 48 kilohertz, which was developed and used for film. And some like 48 kilohertz because they argue that the math done in the processing is easier and sounds better than it is with 44.1. But really there's no proof, only speculation and opinion. But still, speculation and opinion is often a good motivation for going one way or the other. Next is 96 kilohertz. This was developed a few years ago as processing power increased and storage costs diminished. Now this format is used in high quality DVD audio, but it still has no consistent proof that it sounds better than 48 or 44.1. And finally we have 192 kilohertz. And this is also available in high-end equipment, but rarely used because of how much storage and power it requires, with no hard proof of better sound quality. Now, listening tests between 48 kilohertz, 96 kilohertz, 192 kilohertz, all with high-quality converters, are usually and most often inconclusive.